In today's lesson, the TEAS goes as followed: dimensionality and the geometry of location. The student understands that coordinate systems provide convenient and efficient ways of representing geometric figures and uses them accordingly. The student is expected to use slopes and equations of lines to investigate geometric relationships, including parallel lines, perpendicular lines, and special segments of triangles and other polygons. The objective for this lesson will be: we will explore the relationships of the slopes of parallel and perpendicular lines. Hi class, my name is Ms. Molina, and we're going to be going over parallel lines and perpendicular lines. But before we actually go into the equation part of it, I just want to show you guys some real life examples of parallel and perpendicular lines. So here, as you can see, the train tracks are parallel, so that's a good example. They never touch, they keep going. So this is an example of parallel lines that you would see in real life. Also here at the gates, you see that there are parallel lines. They do not touch, have the same distance from each other, all that kind of stuff. Then another example of parallel lines on the football field. How many of y'all have played football before? You see these are parallel lines. They do not touch. They have the same slope, as we're going to see later on. Now examples of perpendicular, we have them intersecting. This is an example of roads that you would see, some streets that you guys drive on. They meet at a certain point, 90-degree angles here. And we're going to keep going on stuff. So another example of perpendicular lines here at the tennis court. You guys might play. Here some more is 4 paths. They meet at a certain point, perpendicular, 90-degree angles. So these are just some real life examples of parallel lines and perpendicular lines. Now we're going to jump into the actual examples of how you get the slopes and comparing that. And we're going to be going over parallel and perpendicular lines and their slopes, and comparing parallel lines and their slopes and perpendicular lines and their slopes. So first off, we're going to write the formula for figuring out the slope. So that is rise over run. This is your slope formula. Rise over run. It also is known as the rate of change. Also, in your regular standard formula equation, it's y equals mx plus b, and your slope being your m. So the m is your slope in your standard equation. Now when going to your graph, you need to be careful and know that when you're going up on your graph, which is your rise, you need to be careful and knowing that your end result is going to be positive. When going down, it's going to be negative. When going right, it's going to be positive, and when you're going left, it's going to be negative. So this is all the information you need to be able to figure out the slope of your parallel lines and your perpendicular lines. Now we're going to go over some graphs and compare these lines to see if whether they're parallel or not. So using our slope formula, we're going to do the rise over run. So we start at one point, we go up 2, and we run 1, 2, 3, 4. So up 2, which is positive, and you're running 4, which is also positive because you're going to the right. So 2 over 4 is equal to 1/2. Now for this line, we go up 1 and we run 2. 1 up, 2 to the right, that's positive. So we have our AB is 1/2, and our CD is also 1/2. So by this result, we figure out that this is a these are parallel lines. And now we're going to go on number 10 to see if these are parallel lines. Already looking at it, we can tell that they're not parallel lines, but we're going to see how with the slopes we can establish that further. So we have our point C and D. We're going to rise 2, and we're going to run 3. So that's 2 up, which is positive, and 3 to the right, which is also positive. So our AB, our CD is 2/3, and now we're going to figure out our AB. So we have it, we rise 2, positive, and we're going to the left 1, 2, 3, 4, 5. Since we're going to the left, that is going to be negative. So positive 2 and negative 5. So clearly seeing here, our slopes are not the same. And here, the slopes are the same. So we can make a conjecture and say that parallel lines have the same slope. So this is an example of perpendicular lines. So we're going to get the slopes of line 1 and line 2. Let's see what we get here. So starting at a point here, we're going to rise 2 times and go 1 to the left. So if we're going 1 to the left, that makes it negative. We rose 2 and went to the left once. This is equal to negative 2. Now for line 2, we get another point here, and we go up 1, it's rising 1, and we're running 2 times. Both of these are positive, rise over run, 1/2 is equal to 1/2. So we have our negative 2 and our 1/2 as our slopes. Now we're going to go on over here, and we have 2 more examples, one of parallel lines and one of perpendicular lines with the equations, but we're looking at the slopes here that are highlighted and how we got the slopes. So going off here, we're going to see that you get a point here, you rise 2 and 1 to the right. If you're going up 2 times, it's positive, you're running 1, so it's 2 over 1, which is equal to 2. And so that's how you get your M here that you plug in. Now going for this one, we're going to see this one also. We're going to go here, we're going to rise 2 and run 1. So we're getting 2 over 1, which is equal to 2. As we can see here, we have our 2 and our 2. So we're seeing here there's a pattern. We have our parallel lines, same slope. We have our 2 and our 2 here. So we're saying that with parallel lines, the slopes are going to be the same. We can make a conjecture now saying that parallel lines, their slopes are going to be the same. So now let's figure out what the conjecture would be for perpendicular lines. Okay, so we're going to get our point here. We're going to rise 1, 2, 3 times up, so it's positive, and 2 to the left, which is negative. So this is going to be 3, negative 2, as we see here. Now here, we're going to get our point. We can start here. We rise 1, 2, and then we run 1, 2, 3. So 2 is positive, 2 up is positive, and we're running 3, which is positive. So here, we got our slopes here, 2/3 and negative 3 over 2. So if we look at the pattern here, for parallel lines, it's the same. For perpendicular lines, we are getting the reciprocal, so the opposite, we're switching the numerator and the denominator to get our other perpendicular line, and we're doing opposite signs. So this one's negative, this is going to be positive. So it is the inverse here. So that is how the slopes here are, what the pattern is. So the conjecture that we can make here is reciprocals, opposite signs. Here, slopes are the same. So those are our conjectures for parallel lines and perpendicular lines and their slopes. So now class, we're going to do just a summary of what we've learned on parallel and perpendicular lines. So for our parallel lines, just a rough sketch of it. They do not touch, and let's say for line 1, the slope was 5. The slope for line 2 would also be 5. So So we're going to put n equals 5 and n equals 5. So the conjecture we're making for parallel lines is slopes are the same. Now we're going to go on to perpendicular lines here. Just drawing a rough sketch of it, it creates a 90-degree angle and they connect at one point. Let's say for line 1, the slope was 5, like we have here, but for line 2, it would be negative 1 over 5, 1/5. So our conjecture here is saying here is slopes are the same, here it's slopes are opposite reciprocals. So this is what the lesson was about, parallel perpendicular lines and how their slopes create a pattern. Thank you guys very much, and I hope you guys enjoyed my lesson.